recording number 1. Okay, the title was PS2, we're multiplying and factoring today, and multiplying special cases of binomials. The central question is, what is the GCF, and how do we use it to factor polynomials? And then we're going to note to do and we have a test to make sure that they're done in full. And that should be easy quiz. We'll do them all together. Okay, the first problem, the directions say, what is the simpler form? What's another way to say what is the simpler form? In one word. Simplify, that's the same thing. What is the simpler form of 5n times 3n cubed minus n squared plus 8. What is the simpler form? Well, that means it's simplified. Use a pencil instead of marker. Or the pen that's a little thinner. Okay, we've just been practicing this. How do we simplify this monomial times a trinomial? Yeah, distribute. Shall we just practice these? Okay, distribute. We have 1 term times 3 terms. 1 times 3 is 3, so we should get 3 terms total. Distribute. Okay, how about you try it first? I'm going to check, make sure you got it right. Okay, I'll read. What is 5n times the 3n cubed? What? Thank you. So the fourth power. Remember, when we multiply, we add. Let's say add, right? The next one's 1 plus 3 means 4 on the exponent. Okay, so now we have to distribute 5n times negative n squared. Anthony, that's 5n times negative n squared. Negative 5n cubed. Remember, when we multiply, the exponents need to change. When we add, it doesn't change. Please don't drink that in here. When we multiply, it changes. Okay, how about Emily Nestor? Last one, 5n times 8. Good, so it's a positive 40n. Are there any questions on using the distributive property to simplify? Okay, we're doing that a lot lately, distributive property. Alright, and the essential question said, what is the GCF? What is the GCF? Greatest common factor. So if I said, what is the greatest common factor? What are all the factors of 8? What are all the factors of 8? 1, 2, 4, that's 7, 8. So they're smaller or equal to. They're not bigger. They're called multiples. Factors are smaller or equal to. We have to divide evenly. So example 2, I'm going to ask what is the GCF of the following polynomial. So we're looking for the greatest common factor. And of 3x to the 4th minus 9x squared minus 12x. So the variables which I used to, but you are used to the numbers. I see fingers in the air, don't shut up, fingers in the air. What's the greatest number I can divide into 3, negative 9, and negative 12? Fingers in the air. What's the greatest number I can divide into 3, negative 9, and negative 12? Good. always put the wrong answer on my hand. So if you're looking at one before, it's because you're holding on my answer and not paying attention. Right. Okay, good. It is a 3. So our GCF starts with a 3. They have more in common, don't they? What else do we have in common, Lexi? They all have something else besides numbers. A variable, they all have axes. So remember, you can't take any more than the smallest guy, because it can't be greater than. So what's the smallest amount of x's that all of them have to give? 1. The smallest guy right there, right, is 1. So our GCF is 3x. If the direction is out for GCF, that's all you have to do. Find the largest number that divides into all of them, and the quantity of variables. What if I change the problem and make the problem 3x to the 4th minus 9x squared minus 12x plus 6? What would that GCF be? 3. Doesn't the 6 have an x? No, so your GCF could just be a number. It could also just be a variable. Okay, or it could be both. So I put that in common. Any questions about that? Okay, we're going to use this GCF word to factor. Yeah? Yes, because guess those tell us how many x's there are. 4, 2, 1. Yes, because if this was, say, a 6, then that would mean x squared would be the most that they can take out. So yes, this one's too play that part. We'll take that off. Example 3. Use the GCF to factor the following. 9x to the 6th plus 15x to the 4th plus 12x squared. Okay, so it's essentially 3 steps to do this. The first step is to identify the greatest common factor, which we just did a problem like that. Step 2 is to write the GCF outside of parentheses. So the double digits appear outside of the parentheses. Double digits appears pulled out on the outside. And then the third step is to divide every term by the GCF, greatest common factor. We just have to write that down and then we're going to practice all the steps. Okay. Okay, you guys agree upon, please, what the GCF is for 9x to the 6th plus 15x to the 4th plus 12x squared? Okay? Do you think you will have to stand up and point to it on your paper so I can see it by the room? Stand up, yeah, it's going to be on sure. You guys stood for so long. Where is it? Yeah, I need to go see it. Good. Good. Okay, there's more than just that. What's the greatest common factor? What's the largest number that divides into all of them, and they have a variable to share? Well, they also have something to say for number. They all have x's. But there's more than that. Look at the smallest number of x's. 6, 4, and 2. Yeah, when you have it. 6, I'm just going to get on the intro as well. Yeah. Good. Okay, well, keep running too much coming on the yep. You get it? Good. Okay. Have a seat. Have a seat. Fingers in the air, please. Oh, shut up. Fingers in the air. Let's start with numbers on items 9, 15, and 12. Good. 3. Fingers in the air. How many X's can we take out that all of them share? Good. 2. What is that? The smallest I have is 2. So 3x squared is the GCF. That's what the answer. That's just a factor. So what we do, what we do is we are multiplying by the fancy form of 1. I'm going to pull out 3x squared and put in the parentheses. If I multiply on the top by 3x squared, I must divide by 3x squared. This is just a fancy form of 1. It's 3x squared divided by 3x squared 1. Anything divided by itself is about 1. Yes, we use this fancy form of 1 a lot in math. That helps with really good problems. 3x squared divided by itself is 1. So we have to do it on every term and simplify. So our answer has 3x squared on the outside, and we will simplify this division, and that will be our answer. Okay? So therefore, what is 9 divided by 3? Then now with the exponents, x to the 6 divided by x squared. Then again, it's going to be a exponent, but they used to say, when we divide, we have to subtract, right? 6 take away 2 is x to the 4th, x to the 4th. Okay? I think, what about this next term? What's 15 divided by 3? 5 and the x's. We have x to the 4th, so taking off 2. So 2x squared. Alright, last one. I'm going to talk to you. And, what is 12x squared divided by 3x squared? And what about the x's? They do, because x squared divided by itself is 1. 2 minus 2 is 0. Equals 0, 5 squared is 1. So there's our answer. That's factor form. Now, we didn't actually change the value of the problem. If I distribute this back in, we get the original problem. And we just pull out what they all have in common. It's very handy when we start our next unit on quadratics. It's very handy to look at factor form. Okay, let's try another one. Example 4, now you know the 3 steps when you see it. Factor the following. Using the GCF. Negative 6x to the 4th minus 18x cubed minus 12x squared. Can you write that in factored form? So 3 steps. Identify the GCF. Write the GCF outside the parentheses. And divide every term by the GCF. Let's have the case. But you do it the same way you agree upon how you do it. I'll put those last example back up so you can see everything we did. What? How much more? Oh, you move this way. Okay. Can you see that now? Oh, yeah, probably. I'm pushing the little bit around back. Okay, find that GCF first. With your partner next to you. Find the GCF. Keep going. Okay, now, let's let me tell. They all have something else in common. They all have in common. Negative, and then you're good. What's your GCF? What's your GCF? There's another thing they have in common. You don't just have one x, they should have x squared. Okay? Okay, so what more detail? Look at our favorite. What do they have in front? They're all negative. Okay, close. More detail. They all have what in front of them. And negative, so GCF is going to be negative as well, because that's something they have in common. Okay, you find your GCF. Okay? You guys realize there's 6 of them all there, but they also have negative, don't they? And then look at how many x's they have. Okay, let's see. Here's there. What number can find into negative 6, negative 18, and negative 12? Here's there. I don't know. Like this? Ask me a negative 6, right? Don't they all have negatives in common? There you go. GCF. Negative 6. Here's there. How many x's do they share in common? That's obviously not 9. That's what I'm going to go. How many x's do they have in common? How many x's? Now, getting more than the smallest guy. What's the smallest guy? 2x squared. So now, you need to put that GCF in front and divide by every term by negative 6x squared. Every term, simplify it. So your answer, negative 6x squared is in the front. Don't forget about that. And then simplify your division. You have 3 division parts to do. Do that one. Okay. Let me get this around for you. Yeah, just run right there. So right there. Negative 6x squared. So we're going to write it negative 6x squared. Okay, so right out here, negative 6x squared. Parentheses, okay. What's negative 6 divided by negative 6? 1. So we're going to write that. X to the 4th, we take off 2 x's. So it'll just be 1 to yep, 1x squared, exactly. Okay. Now, every day 2 is negative 6. We're not subtracting or adding, we're dividing. How many 6's are in the number 18? 3. So then we'll take that. Keep going. Okay. Come consolidate your answer. I haven't checked it off. Okay, ladies in the back. Is that Haley? No? Yes. Not Haley. Aubrey. Aubrey. What do you know again? Abby. Sorry. Abby. This doesn't show. I mean, let me have your friend on the other side. Okay, I do x squared, but here we have negative divided by negative. Positive. And then I don't think the x should be at the end because x squared divided by x squared cancels. So x is gone. And negative divided by negative is a positive. Does that make sense? Okay, but now you're good to go. Okay, that's factoring. We're going to do a couple of the special cases and then the rest is work time. Okay, so we have TCS, so we're practicing multiplying polynomials together. Now these things are called special cases. Example 5. Simplify. 2x plus 9 squared. What does 4 squared mean? And 16, how do you do that? What does 4 squared mean? 4 times 4. What does 2 cubed mean? 2 times 2 times 2. It's a repeated multiplication. So I'm going to show you the wrong way to do this. Don't write this down. It's wrong. But it's all makes sense doing this. Okay, they go, oh, square. Teacher really made my green puffles. Weird. Okay, 2x squared to the 4x squared. Don't understand this is wrong. And then they go 9 squared. Plus 81. That is wrong. But in practice all year, don't do that. So we erase that. Remember, exponents are repeated multiplication. So I have my group, and binomial is really 2x plus 9 times what? 2x plus 9. Repeated multiplication. Now, use your distributive property. We have a binomial times a binomial, which means 2 times 2, which is 4 terms. And then we'll have some light terms to combine. Which means practice your distributive property. Practice the new one. Let me know if you have it and check it off. Okay, you have 4 terms, and then you'll have some like terms that you'll put together. For the first two multiplication. Yes, good job. Yep. Yep. The first term here? No. When you add, you don't change the exponent. That stays 36x to the first power. If you change it to x to the first power, then it's right. And what then is 9? 31. Yes. Yeah, I think she was in a lot of that. Yes, good job. Yep, they're like terms, right? That's the first power. Now when you add, the exponent doesn't change, so e2x plus e2x is just 36x. When you multiply, the exponents change. When you add, the exponent stays the same. Yes. Okay, now we have like terms, right? Yeah. And this guy, 2x times 2x, what's x times x? Oh, yeah, this one is a square. So bring in 2 in that, and then these are the terms when we add them. Okay, then we add 18 into 18 xylophones plus 18 xylophones is 7 squared. So 36x is erased the square and then it's good. Then 2x times 2x, x times x, x squared. 2x times 9 is into x between these two relationships. Yes, when you add those to it. You should have a trinomial. Karen Corsi. It has one more column in its work time. Quiet, please. Okay. Take this off so I can get it. True. What is 2x times 2x? Wow, did you want to pick that? Yeah, true. Thank you. 4x squared. X and x, when you multiply, the exponents change. Okay? Allie, what is 2x times 9? Good. 18x. Let's have it. Nikki. 9 times 2x. Another 18x. And 9 times 9, John? 81. Okay, see how we got 4 terms? Because we had 2 terms times 2 terms. That should create 4 terms. So that's a good sign that we're on the right track. We have right terms in the middle. 18x plus 18x. When we add, this things don't change. It's 36x or 36x squared. No, we add. The exponent doesn't change when we add. It only changes when we multiply, so it's just 36. Okay? X squared is in a different value than x. Do I have any questions? Yes. No, actually that was the wrong way. You're saying when I did that first time, I don't like this and this. Not this. But I'm not going to do the first time I said, don't do this, this is the wrong way. And the reason is because you missed that middle term. Okay, one more problem. This is another special case. Okay. This is also simplified. This is called a difference of two squares. Example 6, a difference in two squares. 6 plus m squared times 6 minus m squared. These are all identical. What's the difference though? Addition and subtraction. Okay? So, here's trans property. I said this is the difference just because it's really like this is the product of a sum and a difference. One's a sum, one's a difference. Okay? You can show your property. Let me know when you have your answer. Be careful with what m squared times m squared is. So let's start on the left side. Okay, and then you have right terms. Find the right terms, put them together. So you should originally get 4 terms. Okay, do this one. And then we have right terms. So just, start it on the left. No, because it's just a positive times a negative would be a negative. Oh, okay. And then we're going to standard form. Remember, highest exponent, descending down the lowest exponent, then in standard form. So then there's exponent first. But what this is negative 6 plus 6 is negative 6 plus 6. Good. Got it. Just a negative times a positive is a negative. So you get a fourth term here, you use your m squared times m squared. Negative m squared, excuse me. Positive m squared times negative m squared is negative m, we multiply the fourth, we multiply that increase. And add them. Okay? This is right here. No, it's the first side. Because we have 6 times m squared. And we have m squared times the negative 6. Maybe that should be right here. Okay, done. What's the first thing when you do on this? Distribute? Oh, we have 2 doms. John, did you tell me the way? Becky? Okay, Grundy. Grundy, sorry to get it on. And Grundy, what did you first? 6. 6, and what is that? 36. Okay? I didn't see that. Can't remember down. Rosie. Okay, Rosie, what do you do next? Good, negative, what she said. Which is what? Negative 6m squared. Okay? Let's see. Oh. Good, what's that? So positive 6m squared. And last step. Okay. What's the last thing? Negative m squared, so we have to multiply 2. M squared is m to the 4th, right? We have a positive times a negative, so negative m to the 4th. Times those exponents. We don't like terms in the middle. Negative 6 million squared, marshmallow squared, plus 6 marshmallow squared. That's negative 6 plus 6. 0. I'm going to write this in standard form though. 36 does not have the highest exponent. The highest exponent is negative m to the 4th. Plus 36 is m to the 0. That's the answer because of binomial. Okay? I have that fixed. You should keep it on your desk. While you do your homework, you should have the notes out. It goes in the same order as your homework. You should not get notes away. But you got your homework calendar to write out your homework is, and the rest of that is yours to work. You got your homework calendar, you have your own pen, or the one I gave you with your job. Okay, write those calendars out. Okay, tonight's homework. Most of them are just GCF or illustrated properties, so they go pretty quick. Page 55, geometry ratio even, which is on 2 pages. Page 71, 1 to 4, that's all of them, 1, 2, 3, 4. And 8 through 22 even. Let me see what canvas if it's, you can see it here. Okay, so there are 2 pages. We have the questions on page 62 today, so what does that mean to do on Thursday? Page 62 is due on Thursday. And we'll answer questions on 55 and 71 next time. Okay, so the rest of the class, you need to have your book out, your notes that go with this lesson, and start on page 55 with the evens, number 2. Make sure you write it down on a separate piece of paper. Is there anyone who's, do you have a book yet? Okay, I have a copy for you. The book's come backwards, so I have, no one else doesn't have a book yet. Yeah, but there's just some distributed properties, so go quick. Okay, so here's page 55 and 62. Oh, I have it, copy 71, I'm going to do that for you. Not in this one. Okay. Someone should have copy page 71, I didn't do that. one. Okay. So I expect you all to look out and you'll be working for near classes, so don't make sure to copy really quick. Rather than do pre-game, I need who wants to be in charge. Alright. We'll put who in charge? Riley and Abby. If they raise a hand, who in charge? They will tell me if you're messing around. And then I'll get copies really quick. It's right there.